In today's video, in a previous video, understanding about the concept, what is a simple linear regression, and what is the base fit line and how to calculate that, what is the intercept, what is the slope, all of these things we are understanding what is the error. Okay, in this video, we understand about the how, what is the cost function, how to find out your base fit line, right? We okay in that particular page that's we have a point, right? And we can't draw hypothetically a base field line, right? It is something like that. We can't draw something like that. So we want to specify how to draw or especially base field line. So for that, we understand cost function and how we changing the okay. This is a let's consider we have a slope of line. Okay. First, understanding some concept of cost function. Okay. So cost function is a j theta of with respect to is a intersect and theta 1 and theta 2 is nothing but 1 by 2m summation of uh, I 1 to m, and basically this is a h theta of x minus y whole is right. And what is this? This is your predicted point, predicted point, and this we are actual point, right? Actual point, and this is your cost function. And what is your aim? Final aim to minimize this cost function. Okay. When talk about the final aim to minimize cost function, minimize cost function, right? This is your final aim to minimize the cost function. So for that, that we have a cost function as well. So first we understand some concepts, and before that we just erase that. Okay. And now we understanding the our base fit line. Okay. So that we have a data set, something like that. Okay. And let's consider your the base fit line is passing through the origin. Okay, and if we simply changes a slope value, the passing through the origin, it's and its equation is a s theta of x is equal to theta 0 plus theta 1 x1. This is your equation of that line. Okay, equation of that particular line. So in that case, what is the aim? Aim is to minimize the cost function. Okay, so we reducing the cost function, and basically simply it is a cost function that we have. So we aim to minimize the cost function. So before that, let's uh, so how to minimize? Okay? Question is how to minimize the cost function. So cost function minimize by changing a cost function minimize changing theta 0 and theta 1 value. It's mean with changing your intercept and the slope for the reducing or minimize the cost function, right? That is our aim. So understanding one by one. So let's start, and let's your a base fit line is passing through the origin, right? It's mean theta 0 is equal to its now intercept is a 0. So your equation is look like, so your equation is look like s theta of x is equal to theta 1 x1, right? When the when your base fit line passing through the origin. Okay. And we have data set something like something we have considered x and y, 1 1 2 2 3 and 3. Okay. And we draw that line something like that, something like that. We have we have data points 1, 2, and 3. Similarly, 1, 2, and 3. This is the x and y, right? And this is your equation of line. And when 1 is between both of you and it's something so here 2 it means someone point is someone here, 3 it means point is someone that's here. And this line is passing something like that. Okay. So this is your base fit line that we are create according to that data set. Right. And let's consider in that case uh, let's assume we have a theta 1 value is equal to 1. Okay. So what is a s theta of x, right? So s theta of x is a 1 if x is equal to 1. Similarly, s theta of x is equal to if x is equal to 2. And similarly, s theta of x is equal to 3 if x is equal to 3, right? When you calculate the theta 1 value, is 1 multiplication of 1. So 0, 1, similarly 2, 1 into 2, 2, like something like that. So we are creating that. So we get it that line. Okay, that line. And what is the cost function for that particular statement? So when we calculate the cost function, okay, so calculating the cost function, what is the cost function? Cost function is the j theta of 1 is equal to is 1 by 2m summation of I to 1 to m. And simply we uh, okay, yes theta of x minus y whole square, right? And similarly 1 by 2 into 3, what is 3? 3 is the number of data points 1, 2, and 3, right? And we simply summation of 1 minus 1 whole square. It means that that value is 1 and y is a 1. Okay, 1 plus 2 minus 2 whole square. What is the yes theta of 2 is this 2 minus this 2. Sorry, minus this 2, and yes theta of 3 is this minus this. Okay, plus 3 minus 3. So is the whole equation become a 0, right? And if the whole equation become a 0, and we draw simple for that, we write one more graph. And this graph with respect to theta 1, with respect to j theta of 1, right? So how this changes are given. So this is the 0.5, let's 1, 1.5, and this is a 2. Similarly, 0.5, 1, this is a 1.5, and this is a 2. Okay, this is your cost function. So when the theta is equal to 1, at that point we have cos theta is equal to 0, right? So the point R come here. Okay, so that point is a theta is equal to 1 and j theta of 0. So there is a point is equal to somewhere something is appending at that point. Similarly, what we will do next is simply reduce the theta value. So theta 1 is equal to 0.5. Okay, theta is equal to 0.5. So in that case, what happening? In that case, simply we calculate. Let's s theta of x. Yes, theta of x is when the base line passing to the origin, right? S theta of x nothing but 0.5 if the if the x is equal to 1, right? And uh, similarly s theta of x become of 1 if x is equal to 2, right? And similarly s theta of x is equal to 1.5 if the x is equal to 3. Okay, for that as well, when we reduce the cos theta, similarly we calculate the cost function as well for that. So cos f1 for that is similarly 1 by 2m h theta of x minus y. Okay, and that's the whole square. So simply 1 by 2 into 3 multiplication 0.5 minus 1 whole square plus 1 minus 2 whole square plus 1.5 minus 3 whole square. So this is a approx give us 0.5. We calculate that small thing. This is a come here as 0.50. Okay, and this in that graph when uh, that theta value is 0.5. So in that particular case, the j theta of 1 is a coming someone, coming someone, and coming someone here. Okay, and similarly, when another we get a theta value, and simply we reduce it. Okay, so what we'll do, I simply perform a task in that particular case. Let's we are considering theta value. Okay, in that case, let we getting a theta is equal to 0. Okay, theta 1 is equal to 0. X means slope is equal to 0. So in that particular case, when we calculate the s theta of x is equal to s theta of x is equal to 0, right? For all of if the x is equal to 1, then all for their all uh, x is equal to, so we get a 0 s theta of x. Similarly, we get a s theta of x 0 if the x is equal to 3 as well, right? So in that particular case, we can calculate the j theta cost function. J theta of 1 is equal to, when you calculate the cost function is a approximate 3, right? In that case, we calculate the small thing because this video is too long. So you calculate in this point is lacking, someone is here. Okay, this is a graph. The graph is not make up properly, so you understand that thing. And this graph is when you do multiple changes in a theta value. So in that case, you in a particular case you make a graph something like that. You make a graph something like that, and this is a gradient descent. Okay, uh, gradient descent. This is graph is a gradient descent. This point is very close to that minimum. Is called as a global minima. This is called a global minima. Okay, so this is for the how much we reducing the cost function, how we get the your base fit line. So this is for the today's video, and we will understand